Welcome, dosto. Today, we're unpacking a roadmap that literally every software engineering aspirant dreams about. You are the hero of this story, and today is your day one to cracking top tech product companies. Yeah, we're talking about FANG. No more tutorial hell. We're going to break down exactly what to study, when to study it, and how to actually master it.
Okay, let's dive into this syllabus. This is our strict 6-month action plan. We've got basics and complexity in month 1. Months 2 and 3 cover core structures. Month 4 is all about core algorithms. Month 5 is conquering DP, dynamic programming. And finally, month 6 is the final sprint, interview prep. I know exactly what you're thinking. Crack FANG in 6 months? Kaise, how is that even possible when the syllabus looks like a massive mountain? Well, the answer is simple. We aren't just going to blindly memorize code. We're going to use smart work, recognize deep patterns, and use real-life, everyday analogies to completely demystify data structures and algorithms. No rote learning, just pure understanding.
Let's start with month 1, basics and complexity, setting the foundation. The biggest rule this month? Pick one programming language, like C++, Java, or Python, and absolutely stick to it. No switching allowed.
Here's your overarching timeline. Remember, you're the hero on a chronological journey here, and this is your blueprint. You simply can't jump ahead to month 5's advanced topics without building those foundational structures in month 3. You have to respect the timeline.
So, before you write hundreds of lines of complex code, you've got to know if it's actually efficient. That's where Big O notation comes in. It's the ultimate efficiency test. If your code works for 10 users, but completely crashes the second a million users log on, Big O is going to tell you exactly where that bottleneck is.
All right, let's move to months 2 and 3 and see how this builds. Core structures, building the building blocks. You've learned a language, you understand efficiency, now it's time to actually store some data.
The absolute most fundamental structure is the array. Technically speaking, it's a collection of elements stored in contiguous, meaning back-to-back, memory locations, accessed by an index. Okay, that's the textbook definition. Let's make it real.
Think of an array exactly like a masala dabba in an Indian kitchen. In a masala dabba, every single spice has its fixed, specific slot, right? If you need turmeric, you know exactly which compartment to reach into instantly. An array is exactly like that. It gives you immediate access to your data because every item has a fixed, contiguous slot.
Next up is the stack. The technical concept here is LIFO, last in, first out. This is a linear data structure where you can only add or remove elements from one end, which we call the top.
Now, what's really interesting about this slide is the real-life equivalent. A stack is literally a roti kadabba. Think about it. When fresh, hot rotis are made, the newest one is placed right on top, and when you eat, you grab the one on top. The last in is the first out. That is LIFO in action. Kind of impossible to forget now, right?
Then we have the queue, which is FIFO, first in, first out. This is exactly like standing in the IRCTC Tatkal counter line or a movie ticket line. Whoever gets in line first gets their ticket first and leaves. Simple, ordered, and fair processing.
As we shift into month 4, we hit core algorithms, processing the data. We're moving beyond just storing data in boxes and lines and actually figuring out how to process, find, and sort it.
For dynamic data, we need flexible structures like linked lists. Unlike fixed arrays, a linked list is essentially a treasure hunt. One node holds some data, and a pointer, like a clue, points directly to the location of the next node. You just follow the clues sequentially to find your data.
Okay, before things get too heavy, I want you to remember one number, 150. You do not need to solve 1,000 random questions. Just 150 to 200 targeted, pattern-based questions on platforms like LeetCode are enough to see massive results. It's about quality and pattern recognition, not blind quantity.
Now for nonlinear structures. Think of trees in coding just like a traditional Indian joint family tree. You've got grandparents at the root, parents on the branches, and kids as the leaf nodes. It's a perfect visual for hierarchical data. Navigating a coding tree is literally like tracing your family lineage.
Brace yourselves because we are entering month 5, conquering DP, the final bosses. This is where most people drop off, but not you.
Let's look at graphs. A graph is simply nodes connected by edges. The absolute best way to visualize this is the Delhi Metro map, or Google Maps. The stations are your nodes, and the train tracks connecting them are the edges.
When you're finding the shortest path from Rajiv Chowk to house costs, you are literally executing a graph algorithm.
So the crucial point is dynamic programming, the most feared topic. But honestly, DP is just smart work. It's just a way of remembering the answers to past problems so you don't have to calculate them from zero again. Imagine a math exam where question 5 is just question 2 plus question 3. If you remember the answers, you just add them up. Remembering it, that's memoization.
Don't let DP scare you. There are 3 highly actionable structured steps. First, identify your overlapping subproblems. Are you repeating calculations? Second, define the state. What variables are actually changing? And third, choose your strategy, either top-down memoization or bottom-up tabulation. Just follow these steps and boom, final boss defeated.
If you're feeling a bit drained, listen to this stat. 2.3 million INR. That's 23 lakhs. Candidates who complete this rigorous journey and land top roles see an average post-prep CTC of 23 lakhs. Let that number reignite your motivation for this final stretch.
Welcome to Month 6, Interview Prep, the Endgame. You've got the knowledge. Now it's all about execution and handling actual interview pressure.
The optimal study balance for this final month needs to be crystal clear. 50% of your time strictly goes to mock tests and mock interviews. This is absolutely non-negotiable. 30% goes to a rapid revision of your core patterns, and the remaining 20% is for polishing your resume and prepping for HR rounds.
Let's quickly summarize the golden rules for this whole 6-month journey. Code every single day, even if it's just for 45 minutes. Don't just solve a problem and walk away. Analyze why your suboptimal solutions were slow. Build your projects in public. And finally, do peer-to-peer mock interviews. Practicing explaining your logic out loud is absolutely crucial.
The roadmap is yours. You have the analogies, you have the timeline. The only thing left is action. Which language are you picking today? C++, Java, or Python? Commit right now, let us know in the comments, and start your day 1. Thanks for joining this explainer, and I'll see you on the other side of your 6-month journey.